Order of operations. There's actually a huge list of operator precedents, not just for addition and subtraction and stuff like that. And you really don't have to understand to begin with this huge list that I'm just about to show you.
Is this chapter 3?
Yes.
And then when we were talking about the hand-tracing chart, I lost that.
Okay, pardon me, please repeat.
We were further down in the PowerPoint because we were talking about the hand trace chart.
Right, okay. Let me finish this one while I'm thinking about it, and then we'll get to the right point. So thank you very much. Okay, so we've talked about how multiplication and division happen before addition and subtraction. If you Google up operator precedents, you're going to see a whole bunch of operators that we don't normally think of. You know, where's addition? Addition and subtraction are priority level 6. Multiplication and division and modulus are priority level 5, but there are earlier ones. Plus plus and minus minus are way earlier than those, so that you can do things like this. X equals plus plus A times plus plus B. Now there's a specific reason that I'm prefixing A and B with the plus plus rather than postfixing them. I'm putting it there. But anyways, since plus plus has a higher operator precedence, it happens first, right? So if I do this, A is equal to 10, B is equal to 10. Now I'm going to make them easier to remember. A is equal to 9, B is equal to 9. As we solve this, A becomes 10. And B becomes 10 because those are higher on the precedence table. And then and only then the multiplication happens. So after this statement happens, X is equal to 100, A is equal to 10, and B is equal to 10. Hope that kind of makes sense. And we're going to hit the idea again when we start talking about plus plus and minus minus in a little bit more detail, because if you word it the other way, like this, it means something different. Things happen in a little bit different order. If we do this, it doesn't behave as cleanly as that. And I'll tell you why later. Just know that there's a much longer precedence chart than just addition, subtraction, multiplication, division, and modulus. What do you need to know about that information? I'm not really sure, because I usually write my code in such a way that there's really very little confusion about it. But for example, equal equal happens a lot after addition and subtraction and all this math, so that you can do things like this, right? If A plus 1 equals B times 2, right? If this happened first, it almost doesn't even make sense. You have to evaluate that, and you have to evaluate that before those values can be compared. And that is reflected on the precedence chart by the fact that equal equal is way down here, below all the mathematical operators. And then there's and or. They have different precedents. And we haven't talked much about and or, so we're not going to even mention them much further, or at all right now. So we were talking about hand tracing, which means that we were almost at the end of this. No wonder it looked strange to me. In fact, alrighty. General crates. Builds custom designed wooden crates. You have been asked to write a program that calculates volume, cost, customer price, and profit of the crates. And so we have a whole bunch of variables: the cost per cubic foot and the charge per cubic foot. The cost per cubic foot, we charge them 23 cents per cubic foot. And then the charge per cubic foot seems to be more. We charge them 50 cents per cubic foot. So it kind of looks to me like there's like 17 cents profit built in there. I probably did not add that up right. 20 7 cents profit. Then we ask them for the length and the width and the height, and we calculate the volume. We calculate the cost, which is going to be the volume times the cost per cubic foot. And then we calculate the charge, which is the cost per cubic foot times the charge per cubic foot. And then the profit is the charge minus the cost. So here's how we want the program to look. The simplest version would be this. Build what size crate. Not create. You know, and we're going to ask for a 2 by 3 by 2 crate. Or we could spell it out individually, right? Height equals 2, width equals 2, and length is equal to 2. Something like that. So instead, you know, crate length equals question mark, and we type in a value. And then it's going to ask something like crate width equals question mark, and we're going to type in another value. And then crate height equals question mark, and we're going to type in another value. Then it's going to calculate something. It's going to say the volume of the crate is equal to 24 cubic feet. And then it's going to tell us the cost of the crate. Cost to build a crate. And I can't do that in my head. 24 times 0.17. $4.08. Did I give something?
608.
What was I looking at then?
I don't know. I might have done it wrong.
24 times 0.17.
7, 4 is 20. Yeah, 3.
Okay, okay,
4.08.
okay. And then it's supposed to charge us the charge of crate. Which is 24 times the other value. 0.5. So it'd be 12. And then the profit, which is 12 minus 4.08. That would be our first run at the program. What might we do to improve it? We might let them enter a lot of crates. How many crates do you want? Maybe they're all going to be the same at that point. Or how many crates do you want? What is the size of the first crate? What is the size of the second crate? What is the size of the third crate? And so on. But I'm comfortable just building it like this, although I'm going to go and sneak a peek at how they did it. Yeah, that's exactly what they did. They asked the user to enter the dimensions, and then they calculated all that stuff. Well, let's build this application. So I believe we're on lecture K. I believe I need my boilerplate. I'm going to go grab it. Add a new item. C++ class, I'm going to change the name of it. What? No, not a class. C++ file, I'm going to change the name of it from source to lecture K as well. Then I'm going to paste my boilerplate. And then I'm going to bring my notes back up because I'm going to eyeball all the data that I need. We know we're going to need a length and a width and a height and a volume and a cost and a charge. And also they wanted us to define two constants. Charge per cubic foot and cost per cubic foot. Well, let's define the constants first. So I'm going to make these doubles because I never recommend using floats. Doubles the default floating point data type. Cost per cubic foot. This is annoyingly long to type, but it's good programming. Equals 0.17. And double space charge underscore per underscore cubic underscore foot equals 50 cents, so 0.50. And now we need those variables, the length and the width and the height and all that stuff. Normally I recommend putting them all, separately. This time I don't really mind kind of declaring them all at one point. Double length, comma width, comma height. Those are all measurements, so to me they kind of make sense to declare them all at the same time. And then on the next line, the cost and the charge and the profit. Double cost, comma, charge, comma, profit. And I could have declared that all on one line, right? I just kind of grouped them into what thematically kind of made sense to me. And yet again, the screen is... All I can guess is that people play basketball in here and they bounce balls off them. Fair enough. Yep. That's actually not necessary for this one. We just added it to our boilerplate because last lecture we wound up trying to use some of the things inside CMath. I don't even remember what. What did we need this to get? So I'm going to do a Google on it just to remind myself. Pi?
Yeah, that was for pi.
That was for pi? All right, it's moronic. You have to do that to get pi out of it, but whatever. Okay. All right, what are we going to do first? We're going to ask them for the length and the width and the height. See out, error, error, quote. Acme Crate Company. \n. See out, arrow, arrow. Length of crate, question mark, space, end quote, semicolon. And let's let them type it in, so we need a CIN. CIN, arrow, arrow, length. And then just to frustrate the people taking notes by hand, I'm going to copy and paste these things and change it to width and height. And now would be a good time to compile it and make sure it worked. But we're not doing anything with that data. Yeah, but compile early, compile early. compile often, make sure that we don't have any syntax errors as soon as possible. That seems to be the case. Now we can start doing our calculations. We need to calculate the volume, and I forgot to declare a variable for volume. Usually I just declare my variables as I go, but I was trying to be cool and put them all at the top. Profit, comma, volume. So I just added this. I didn't have to declare it here. I could have declared it right when I was about to use it. But then again, since I've gone to the trouble of trying to stick them all up here, why not stick with tradition? So volume equals length times width times height. Now we can calculate the cost and the charge. Cost equals volume times cost per cubic foot, and charge equals volume times charge per cubic foot. Those variable names are so long I'm tempted to just copy them, but I'm gonna rough it. Cost equals volume star, and in all caps, cost underscore per, and nicely enough it started popping it up for me, so I can just click that, double click it, and hit enter. And then the same thing for the charge. Charge equals volume star, and in all caps, charge per cubic foot. I see it pop up here in my little IntelliSense helper. Now if I was really super cool, I would echo all my input, meaning I would display the length, the width, and the height as well as the volume. That's going to take a little bit of typing. Cout arrow arrow quote, crate dimensions, end quote, or space end quote, arrow arrow, length, arrow arrow, quote, space quote, semicolon, and then I'm going to do just a couple more couts to print the width and the height. I didn't add an ENDL on purpose because I want all of this to be on the same line. So cout arrow arrow quote, no quote, sorry. Cout arrow arrow width arrow arrow quote space quote, arrow arrow height arrow arrow ENDL. It might look groovier if instead of spaces between them we put X's, right? Because it's a 3x4x5 crate. I think I'm going to go make that change. I think I'm going to put an X inside that space and an X inside that space. And I'm going to compile and run it again. If I have any syntax errors, I'd like to catch them early. All right, length of crate. 10, 20, 30. Crate dimensions, 10 by 20 by 30. Okay, I'm kind of happy with that as my output. That's called echoing your input, and the reason you do that is just to give the user a clue as to what they typed in so that if they've made a mistake, they spot it. Just like when you're making a purchase from an online company, you like to see when they displayed not only your cost, but you know, your billing method and your address and things like that, what you ordered. Now we can put the rest of the information. We can put the charge, we could put the cost, and we could put the profit. We haven't calculated the profit yet. In my mind, we should calculate the profit before any of this output, and I wish I had done so here. So I'm going to hit enter 2 times, move to the line charge equals, and the profit equals charge minus cost. And now let's just display that stuff. See out, arrow, arrow, quote, cost equals $, end quote, arrow, arrow, cost, arrow, arrow, ENDL, and do the same thing for the charge and the profit. So I'm just going to copy and paste that line again. I'm going to copy all that and paste it 2 times. The second time is going to be the charge, and the third line is going to be profit. All right, it's a 10, 20, 30 crate. That's an expensive crate, but I guess it's huge. Something that's 30 feet long is pretty big, so okay. And then press any key to continue.
6,000 cubic feet.
Yeah, yeah. If it was an itty bitty one, like a foot by foot by foot, 1, 1, 1, yeah, cheap crate. Alrighty, there's a couple of ways, couple of directions I could take this. The way that I'm tempted to do, but I think that I'm going to blow it off, would be to put it inside a loop to where we keep asking them for new crate dimensions, and then at the end we print the total, right, the sum total. But I don't feel like putting a loop in it. I do feel like showing you something that I don't really want you to do, because it's going to involve making reckless changes to this, and then I'm going to undo it all. So just kind of watch. But firstly, let me make sure that everybody's caught up. All right, guys, I had the recorder off for a minute. What I've done is I cut all the variables out. Don't do this because I'm going to undo it towards the end. And then I pasted them inside something called namespace. Namespace data, curly brace, and then all of our variables, and then close curly brace, and that's above main. But if I try to build it and run it now, I get a gazillion errors. Why? Because it does not know what these variables are anymore. Well, where is link defined? It's defined in the data namespace. So I'd have to come down here and do data : : Oops, width is another one. Width : or data : width. Height is another one. Data : height. Right, there's a whole bunch of them, right? But at least they're safely tucked away in their own name, so that if I had another file, inventory.cpp, and they needed some of those same variables, something called cost and something called profit or whatever, we wouldn't have name collision when we tried to link the two together. This namespace should actually be the name of the file. But we didn't do that. We just called it data. But that's okay as long as there's no other namespace data that has the same global variable names in it. But how do I fix that? I don't want to have to go in and modify all these variables to have data : in front of them. I can do this. I can do that using thing. Using namespace data, semicolon. Now it's all magically fixed. What the program does is if it hits a variable, like charge, and it doesn't find it, it searches all of the namespaces for it. And it does indeed find it in the data namespace. So it's assuming that it's available in one of the, it makes everything inside that namespace available to it as though it had been defined as not being part of a namespace. I'm not expecting you all to get that 100%, but I did want you to see what a namespace is. It's a way of cordoning off a block of data so that you can put some global variables in there that are kind of protected from global variables in other files. And what do I mean by kind of protected? It means that the likelihood of name collision is greatly reduced. But if you're going to do that, then you have to refer to the variable names by their full name. Data, : length, data, : width, data, : height. And if you don't want to refer to them by their whole name, then you do using namespace data, which says, I'm going to blow off using the data : . And so somewhere in some of these files, you can be sure that there's a namespace std that's got cout and cin and all those other things defined in it. Now the namespace std is actually defined in a whole bunch of different files, not just one header, but in a whole bunch of them. And that's kind of why it's considered poor taste, poor programming style to put using namespace std, because you're actually bringing in a whole bunch of stuff, a whole bunch of definitions from a whole bunch of different files. And we should be doing std : cin and std : cout. It's just so much easier to type that I go ahead and demonstrate it that way. All right, now I'm going to undo all those changes. See how many undos I have to do. Almost. There. Except hello world needs to go away. All right. So we have solved the problem that the chapter set out for us to solve. And ours looks pretty close to theirs. About the only difference is we display the dimension, our dimensions, and they do not. One thing I want to remind y'all of is that if you run it, it says enter the length of the crate. I can fill up the keyboard buffer ahead of time. It's a 10 by 20 by 30. 10 is going to get stored in length, 20 got stored in width, and 30 got stored in height. Just because that data was left out there waiting to be read. This went into the first variable, this went into the second one, and this went into the third one. Now, do I recommend you type your data like that ahead of time? No, but it kind of illustrates something going on behind the scenes, which is that these things are pieced out. It's so-called tokenized, so that each variable fills only, each element goes into only one variable, which is why you use getLine if you need data that has spaces in it to prevent that tokenization, to prevent it from chopping it up to spaces. And we are done with chapter 3. Any questions over that? Do we want to make it loop? It would not take very long to make it loop. Yeah, we're going to make it loop. So, go up to the top of the program, right here, after or even before where it says Acme Crate Company. We need a variable that's going to let us know whether we're going to keep continuing or not. So I think I may use the word continue. String space continue. No, continue is a keyword. That's a very bad choice. How about repeat? Okay, repeat didn't show up as blue, so it's good. Equals equals quote y. I mean, that's going to be the value that lets us keep repeating. But I don't know why I put 2 equals. How do you assign a value? 1 equals, and then what's 2 equals used for? Comparisons, yeah. And then so while parentheses repeat equals equals quote capital Y end quote. Now I need an open parentheses after the while, and then I need a close parentheses way down further. So I'm going to put an open parentheses here.
Double equals is like equating something.
Yeah, it's the equality operator, is equal to. Single equals is a set operator, it assigns. Okay, so you saw what happened when I typed in while and then I added an opening brace. It automatically created a closed brace, but that is not where I want it. So I'm going to backspace over that closed brace, and I'm going to pick a better place for it. What do I want? Where do I want it to be? How about here after we display the profit? Like that. Now this is not our final solution because it's not going to ever let us get out of it. But I'm going to make sure that it loops. I'm going to go ahead and run it. It's a 10 by 10 by 10 array. It's a 20 by 20 by 20 crate. I don't know why I called it an array. A 40 by 40 by 40. It's not letting me bail out of it. It's an infinite loop. So I'm going to ask them if they want to continue. So here before my closing brace of the loop, in fact, I'm going to put a comment here.
Where'd you put the opening brace on that loop?
Let me show you. We could have put it up at the very top, but instead I did it right here. Underneath double cost charge profit volume, and then my first line was to declare my loop control variable, string repeat equals y, and then I did while repeat equals y, and that's where my opening brace was. Once you've got your while loop in place, notice this little block here, minus sign. Whoops, it's gone. Notice my function. Whoop, now that's gone. I'm collapsing those sections. You could just do that to minimize the appearance of stuff on the screen. If your code is too long and it's hard to figure out the general flow of things, then you can collapse sections and then you can uncollapse them. Okay, so above my end while, where's my end while? Where's my closing brace? It's after I print out the profit, but before I do the pause. And so all I did is add a closing brace and a comment that said end while to kind of help me keep track of things. Above that, I want to ask them if they want to continue. Cout error error quote, continue question mark, capital Y / capital N, colon, space, end quote, semicolon. And then we're going to read into our variable that was called repeat. So CIN error arrow repeat. But just because we haven't talked about loops a lot doesn't mean that we can't use it here, right? In this particular case, it's pretty easy to follow the logic of what's going on. It's going to get all that information. It's going to display the profit. That it's going to ask us if we want to continue. And a loop is just like an if statement, except once it hits the end of the body, it goes back up to the top and repeats the check. Is the condition still valid? Whereas an if statement just, once it hits the end of the body, it keeps going. That's why it's called a loop. It goes back up and repeats it. Now I'm going to run it and make sure that that works the way I want it to work. Length of crate, 1 by 1 by 1. Do I wish to continue? Y. 2 by 2 by 2. Continue? Nah, I'm tired. All right, so we're done. We could be keeping a tally of all the costs and all the charge and all the profits. That'd be kind of neat, but I think that'd just, complicate our brilliant, cute little example here. We are going too far, but why not? If I wanted to allow them to enter a lowercase y, I could modify this statement. Now in Python, this is the word you use for or. Brilliant, huh? Beautiful, simplistic. Not in C. In C, 2 vertical bars. Shift backslash, the one above the enter key and below backspace is your or symbol. So while repeat equals y, or repeat equals lowercase y, right?
Do you have to say repeat a second time?
You wish that it worked like this, right?
That was the idea.
Yeah, you have to put the whole thing. And the reason for that is this is a Boolean operand where each side of it has to be an this is a Boolean operator where each side has to be a Boolean operand. This would evaluate to true or false, but how is y here going to evaluate to true or false? It's not going to. So each side of the OR has to be a complete expression. You know, and we could go nuts if we wanted to. We could do or repeat equals yes, or repeat equals capital yes, or you know, you can go crazy. And we would probably want to come up with a better solution than just listing a whole bunch of repeats. Like we could convert the string to an uppercase, right? And then we could just pull out the first character of the string so that no matter if they type yes or Y or whatever, but I didn't want to make the example that complicated. But this is a pretty good example. Pardon me?
What the double bar? What key did you press?
That is Shift / the key above the enter key.
I'm done. I'm fairly done. Okay.
Nope. That's kind of like where's tilde, right? You know, tilde actually means something. Well, where is that? Okay, it's Shift ''. Well, where's that? It's next to the 1 key. Yeah. So you're not expected to know where every single obscure character on the keyboard is. There's also an AND. If you've done programming and you've heard and you use the word and in this language, it's like that. Now that would be stupid. It can't equal both uppercase Y and lowercase y. So I'm going to change that back to being an OR. See, I love it when y'all ask questions like that. All righty, chapter 4. Making decisions, which is going to be if statements, for example. This is one of those chapters that we might plow through pretty quickly because we've already been talking about these things. Relational operators. Greater than, less than, greater than equal, less than equal, pure equals, and in earlier schools, you use that to mean not equal to, but not in this language. In this language, and in a great many other languages, you do exclamation point equal, which you pronounce as not equal. Something to note about these. These are all pretty self-evident. You know what if x less than or equal to 3 means. However, it's not immediately obvious. If we do this, if x is less than 3, then cout yes. And then if x is greater than 3, cout no. What's it going to print if x is equal to 3? It's going to print out absolutely nothing, and that's probably not my intent. I probably intended it to either print yes or no. So one of those needs to be an equal sign, like that. That's the only way to catch it, the boundary condition. So the opposite of less than is greater than or equal to. And conversely, the opposite of greater than is less than or equal to. Just kind of have to tuck that away in your brain, because if you think you can write the reverse of the expression by just flipping the less than to a greater than, it's not going to work. You better make it less than or equal to, greater than or equal to. You better think real carefully about it. And then the opposite of, and this one is pretty obvious, equal is greater than, excuse me, not equal. Chapter 4. Relational expressions. Right, a statement is not an expression. we'd have to wrap this in a statement for it to be a statement like this, right? If 12 is greater than 5. If it's just an expression, the relational operators, less than, greater than, or whatever, evaluate to a Boolean value. This is true. This is false. 7 is not less than or equal to 5. So if we set x equal to 10, then x equals 10 is true. X not equal 8 is true because 10 is not equal to 8. And x equal 8 is false. We could prove that to ourselves by going back to our code. And let's put this up at the very top of the program so we don't have to keep repeating this stuff. X equals 10. C out, arrow, arrow, x equals 10, arrow, arrow, ENDL. And it's going to print out true. Whoops. I forgot to make that a data type. int space x equals 10. All right, it's griping at me. I would have to put these inside parentheses to get that to work. Shucky darn. Here's what I'm going to do instead. Bool, and then b just for Boolean value, equals x equals 10. And maybe I'll put parentheses around it to make it really stand out what it's doing. So bool b equals parentheses, x equal 10 close parentheses, semicolon, and then we could C out b. C out error, less than b, less than ENDL. And it's going to print out that it's true. No, it's not. It's going to print out 1. Okay. 1 is equal to true, 0 is equal to false. Change it to something that's not true. Like x is greater than 20, right? That's not true. So it's going to print out 0. We could base our if word, our if condition on that. We could do this, but normally I don't. If b, then do something. But usually if I was going to do that, I would just do this. If x is greater than 10, right? Because that's a lot clearer. A Boolean variable is sometimes called a flag. Because if we did this, we're flagging that we want something to happen later. I want something to happen if x is greater than 10. I'm going to leave that alone for now. I think I'm just going to leave it like that. But I should probably add a comment. X greater than 10 is a relational expression that evaluates to true or false. So we store that, or we can store that, in a Boolean variable. Boolean variable to use later in an if statement or a while or something like that. So 0 is used for true, 1 is used for, 1 is used for true, 0 is equal to false. Don't type this, but that means that you can do strange things like that. If 1, C out, hello, \n. And then I'm going to copy and replace that and say if C out, if 0, C out goodbye. When I run it, it is going to print hello, and it's not going to print goodbye, because 1 is a true and a 0 is a false. That can allow you to write some really stupid expressions like this. if x minus 9, see out hello, and then if x minus 10, and I'm getting kind of cryptic here, and I'm going to delete this thing because it's kind of stupid, but when it runs, it is going to print hello, but it's not going to print goodbye. Why? Because since x is equal to 10, 10 minus 9 is 1, which is true, so it prints hello. But 10 minus 10 evaluates to a 0, which is false. The real reason I'm going in this direction is to make sure you don't do something like this. If x equals 10, it's not that 1 equals true, it's any non-zero value equals true. So if x is equal to 10, see out arrow, arrow, quote, yes, backslash n, quote, semicolon, and then copy that and change it to 9 and make it say no. Notice that I'm using single equal signs, and this is the error. And a lot of languages, such as Python and Java, would not even let this. It would call it a syntax error. This is going to flag it as a warning, I hope. But it ran. And it printed both yes and no. How is that possible? X is not equal to 10 and 9. Well, what's going on is when you use a single equal sign, that means a sign. And so the 10 gets copied into X. And then it's evaluated. Well, non-zero means true. So X has been erased, whatever its previous value is has been erased, and now it checks. Is this expression non-zero? It is, so it prints yes. Then we go to the next line. It's also a single equal sign, so it's an assignment. So 9 gets copied into X, and then that gets evaluated. It's still non-zero, so it also prints no. So if you use a single equal inside of a while or an if, you destroy the prior data that was stored in there. And then it evaluates that. So if we put a 0 here, X gets wiped out. 0 is stored in X, but then when it's checked, is the condition non-zero? No, it is not, so it's treated as a false, and so it does not print out though. And it's okay if that doesn't totally make 100% sense. But what I do really want to hammer in is that if you use a single equal rather than a double equal as part of your Boolean expression, you're destroying data, and you can't really predict in advance whether the if statement's going to trigger or not. It's certainly not going to trigger in ways that you expected. We had set x equal to 10, so if we did if x is equal to 9, we were expecting this not to trigger, but it did. The if statement. If it is raining, take an umbrella. If it is cold, wear a coat. In fundamentals, that was called a selection. Selectively run some code. And we drew cute little flow charts. This is a single outcome, if. Because if it's true, it does something. If it's not true, it does nothing. You can do a whole bunch of things if it's true. But you better have a curly brace there, and then a closing curly brace there. If you have just one line in your if statement, you don't have to have curly braces, but I recommend them anyways. So back to my code. Now that I've confused us by doing all of this stuff, I'm going to delete that, but I'm going to make it like this. If, parentheses, b equals 10, then C out, angle b is 10, backslash n, end quote. I could leave the curly braces out and it would work just fine. Because a single line of code can serve as a block. That would work just as well. But what if I wanted to break that into two statements? What if I also wanted it to do something else, like this? It's going to be hard to even space it out and make it accept that. Isn't that cool? Question mark, backslash n, end quote, semicolon. See, it's fighting with me. It's fighting with me very hard because it understands that to the language, since there's no curly braces there, that this is the only line that is subordinate to the if statement. But I'm going to keep fighting with it. I'm going to pretend that this is Python and that if b is equal to 10, it's going to do both of these things. And when I run it, success, it printed. Well, it didn't print b is equal to 10. Oh, that's because b is a Boolean variable, and it's crazy that it's letting me compare a Boolean variable to a number. Other languages would not have let me do that. I meant for that to be x, and I apologize. Come back down here and change that if x is equal to 10, and then make that say x is 10 right there. Now when it runs, it's going to print both things. It's going to make it look like it's working, right? It says x is 10. Isn't that cool? But what if this expression is not true? What if I made it x equals 20? We know that x is not equal to 20 because it's equal to 10. And we could reinforce that just by putting x is equal to 10 there. It's already defined up above. That's just to make it clearer. So it's not supposed to print x is equal to 10. Isn't that cool? Right? Because this case is not true. What does it do? It skips printing out x equals 10, but it goes ahead and prints isn't that cool? The reason why is because if you don't have curly braces, then only the first line is treated as a block of code. It's as if the code looked like this. That's exactly how it's treated. Unlike Python, where indentation level dictates what is a block of code and what is not. Here, a single line is a block of code, but if you want more than one thing to be in a block of code, you use curly braces. I don't even know what comment to add to that to explain it. So I just hope it kind of sinks in. I guess I could copy and paste and add a comment, but meh. I guess I could undo that. I could undo that. I could tab this back over and add a comment. Oops, the second cout always happens. You would have to use curly braces to make it part of the if block. So if you're going to execute that chain of commands there, but you wanted to make it subordinate to the if statement, you'd better have a curly brace there and a curly brace there. General format. We already know in this particular language you have to include your expression inside parentheses. And it's a good idea to always use the curly braces, even if there's only one statement, to make it very obvious that if you came back in and you needed to add some statements to it, it would behave the way you expected it to. Sometimes you will see me, in order to save space, do dumb things like that. I'm just doing that to save space on the screen, right? If A equals 10, then cout something. That's the only reason I'm doing it like that. Usually, even if it's a single statement, you should have the curly braces, just for clarity and to make it easier to modify later. But it pads out the length of the code. Here's a big source of bugs, and I've done it. It's not, I mean, yeah, it's a newbie error, but it's so easy to make that it's not just a newbie error, which is do not place a semicolon after the if statement, right? Do not do this. If parentheses x is less than 0, end parentheses, semicolon. All right, I've got a problem here. What's my problem? Okay. My problem is because I've tabbed this wrong, and so it's messing up the rest of the tabbing. I'm going to back tab that one, but I'm going to put a tab here. And it's kind of fighting with me. It's because logically I've goofed things up. Cout, arrow, arrow, quote, x is less than 0. But we know it's not. And it keeps fighting with me, and so I'm stubborn, and I keep tabbing it back. The reason it's fighting with me is because of that semicolon. I have written an invalid chunk of code here. Right now, it prints x is less than 0. Why? We said x equal to 10. There's no way this is true. It's because of that semicolon. That semicolon is the same as that. If x is less than 0, do nothing. Then go ahead and print out x is less than 0. This statement happens no matter what, because we had a semicolon here. In general, just like in Python, anytime you tabbed over, you had to have a colon on the line above it. In this particular statement, anytime you have a curly brace or a tab, you better not have a semicolon on the line above it. Let me give you another example. We gave a demo of a while loop. I'm going to call out that this is an error. Code is broken because never put a semicolon after the if line. Another example. While parentheses x equals 10, semicolon. And I'm trying to write a really cool loop here. Even though we don't know all that much about loops yet, I'm going to cout, arrow, arrow, cool, exclamation point, \n, and then I'm going to subtract 1 from x minus minus. That should print the word cool out 10 times. I'm sorry, I meant to make that say something different. Let's make that say while x is greater than 0, right? And so we go into this. It's true, x is 10, so it's greater than 0. It's going to print out cool, and it's going to subtract 1 from x. No, it's not. It should work that way, but we short-circuited it by putting the semicolon there. Just like we short-circuited this if statement. When I run it, I'm not going to like what it does at all. It's stuck. It's now in an infinite loop. Infinite loop because this is executing forever, and it's because that semicolon treats it like this. While x is greater than 0, do nothing. Well, x was, in fact, greater than 0, so it's going to do nothing forever. Never put a semicolon after an if, never put a semicolon after a while, never put a semicolon after a for, or else it breaks the code in one way or the other. I'm going to comment this out because it broke the code. But then I'm going to explain why. And since we missed me uploading the homework assignment on Tuesday, I'm not going to give you all a new one.
Can you explain the x dash dash?
Yes, yes, yes. Have you seen X++? Have I been using that?
You used that a little bit last time.
Okay. X++ is the same as x equals x plus 1. It's also the same as if you took Python and you learned that syntax, x plus equals 1. It's called an increment. Plus plus means increment. Increment means add 1 to it and store it back into itself, just like that.
Is that what a subtraction is?
Exactly, but it's called decrement, right? X minus minus is decrement, which is x equals x minus 1, which is the same as x minus equals 1 in Python if you learned Python. So all three of those are synonymous. Why are there so many ways? Well, this is just a specialized syntax for it. Incrementing and decrementing happen so often that the inventors of the C language decided to make an operator that just did that. The inventors of Python did not see fit to follow that example. But that makes sense, right? I mean, not that we've talked about while loops, but if we went in here and x was greater than 10, what we're trying to do is print out a message and then subtract 1 from x so that the next time it goes into it, x is now equal to 9 and 8 and 7 and so on. But it's broken by the fact that there's a semicolon there. And I'm going to add that as a comment. This fails because of the semicolon after the while. And it's about time to stop. We ended on slide 16. Slide 17 is going to be just talking about else, I bet. Nope. But we're getting there, real close to it.
Can you run now?
Yeah, but let me make the Dropbox first. Then I will get right to that. I'll get back to it. All right, which part do you need? All the way at the bottom? Okay, okay. And I'll walk around and make sure everybody's doing okay.